Have you ever really stopped to think about what's actually going on inside your computer? I mean, really think about it. We use these mysterious black boxes every single day, right? But for most of us, the magic happening inside is a complete unknown. Well, today we're going to pull back that curtain. We are going inside the black box. Think about it for a second. You move your mouse, you see the little pointer, you click an icon, and poof, a program opens. It feels instantaneous, totally seamless, like magic, right? But that one simple click, it kicks off this incredible, lightning-fast journey through layers and layers of hardware and software. So the big question is, how does it do that? How does that click travel from your finger, deep into the machine's core, and back to your screen in the blink of an eye? Let's follow the path. So to answer that question, we have to start at the very bottom. I'm talking about the engine room of the computer, the hardware. This is the raw, physical stuff where it all begins. It's the silicon, the metal, the electricity. This is the physical home for our entire digital world. And here's what's kind of wild. All the incredible complexity of modern computing, everything from watching movies to sending rockets into space, it all boils down to just 4 fundamental actions. That's it. No matter what you're doing, the computer is just doing some combination of these 4 things. It's processing data with its brain, the CPU. It's storing that data in memory. It's moving data around with things like your keyboard and screen, and it's controlling that whole process. Everything fits into one of those 4 boxes.
Now, to really get a grip on how this hardware works, we need to understand the difference between 2 key ideas. Think of it like building a house. The computer architecture is the architect's blueprint. It's the what. It's the grand plan that says what the system should do. Then you have the computer organization. That's the how. It's the actual physical wiring, the plumbing, the nuts and bolts that make the blueprint a reality. One is the logical idea, the other is the physical thing. And at the very core of all this is a relentless rhythm. The processor, the CPU, it's constantly doing this 2-step dance, fetch and execute. It grabs an instruction from memory, that's the fetch. Then it carries out that instruction, that's the execute. Fetch, execute, fetch, execute. And it does this, wait for it, billions of times every single second. This simple 2-beat cycle is the fundamental heartbeat that makes everything else possible.
Okay, so we have this incredibly powerful hardware engine, right? But on its own, it's just raw, uncoordinated power. It's chaos. To make it actually useful, we need a manager. We need a conductor to bring order to all that chaos. And that is the job of the operating system.
Seriously, imagine a world-class orchestra full of the most brilliant musicians, but there's no sheet music and no conductor. What would you get? You just get noise, a total mess, right? Not a symphony. Well, the hardware components, the CPU, the memory, the storage, they're those brilliant musicians. They're incredibly powerful, but they need something to tell them what to play and when to play it. And that something, that conductor, is the operating system, or the OS. It's the master software that sits between you and the hardware. Its job is to manage all the computer's resources, making sure every program gets its fair turn using the CPU, that it has enough memory, and that it can talk to things like your printer or your hard drive without everything crashing.
A huge part of that management job is basically being an expert juggler. The OS is constantly scheduling tasks. You've got the long-term scheduler, who's kind of like a bouncer at a club, deciding which programs get to come in and run. Then there's the medium-term scheduler, managing which of those programs get to hang out in the main memory. But the real star is the short-term scheduler. This one is making decisions constantly, thousands of times a second, deciding which exact process gets to use the CPU right this instant. It's this high-speed juggling act that lets your computer feel like it's doing a million things at once. All right, so we've gone from the raw hardware all the way up to the OS that's masterfully conducting everything. But there's still a really important piece of the puzzle missing. We have this perfectly managed machine, but how do we, as people, actually talk to it? This brings us to the final and maybe most important layer in our journey, the bridge between us and the machine.
And that quote really says it all, doesn't it? You can have the fastest processor in the world, the smartest operating system ever made, but if a person can't figure out how to use it, the whole thing is basically a very expensive paperweight. This is where the fascinating world of human-computer interaction, or HCI, comes into play. It's all about designing that crucial connection. HCI is basically the science of making technology work for people, not the other way around. It's an entire field dedicated to building that bridge, focusing on how we talk to computers and how to make those conversations as easy, efficient, and, as pleasant as possible. It's equal parts art and science.
And building a bridge like that is not a one-person job.
It takes a whole crew of different experts. HCI isn't just about writing code. It pulls in knowledge from psychology to understand how our minds work, from cognitive science to learn how we think and solve problems, and even from ergonomics to make sure that what we're building is physically comfortable and safe to use. It's a true team effort.
So, to design better computers, the HCI experts realized they first had to understand the other half of the conversation, us. The model human processor is just a simple way to think about how we work. We take in information through our perceptual system, that's our eyes and ears. We process that info with our cognitive system, that's our brain, and then we act on it with our motor system, our hands moving a mouse or typing. By understanding our own little input-process-output cycle, designers can create technology that fits us better.
So now we get to the part of the bridge that we actually see and touch every single day, the user interface. This is where the real conversation between you and the machine happens. And let me tell you, that conversation has changed a lot over the years.
In the early days, talking to a computer meant using a command line, like in the old hacker movies with the blinking cursor and green text. You had to memorize all these weird cryptic commands just to get anything done. But then the graphical user interface, the GUI, came along and changed everything. Suddenly, instead of typing, we could just point and click on little pictures. The conversation became intuitive, something you could explore and figure out, not something you had to memorize from a manual.
But a good conversation is about so much more than just pretty icons. Designing a great interface means thinking about all of these things. Who's the user? A kid? A scientist? What are they actually trying to do? Does the design help them do it faster and better? And hey, is it comfortable and safe to use for hours at a time? A really great interface finds the perfect balance for all these needs.
So, let's put it all together. Let's trace that single click we talked about at the very beginning. 1. You decide to act and you click the icon. 2. The HCI layer, the graphical interface, catches that input. 3. It tells the operating system, our conductor, what you want to do. 4. The OS schedules the task and tells the hardware engine to get to work. The CPU starts fetching and executing billions of instructions. And 5. The result, the application you wanted, appears back on your screen. The whole loop is complete.
And that's really the big takeaway here. What feels like a simple, instant thing is actually this incredible, high-speed dance. It's a perfectly choreographed performance between you, the user, and all these hidden layers of design, management, and raw power, all working in perfect harmony. Every seamless experience you have on your computer is built on that invisible dance.
And all of this leads us with a really fascinating question for the future. We've gone from typing commands to clicking icons. Now we have voice assistants, virtual reality, AIs that can guess what we want before we do. As our machines keep getting smarter and smarter, how is our conversation with them going to change next? What does the user interface of tomorrow even look like? Definitely something to think about.